Now I would like to introduce Brian Glinsman to you, Vice President Multicore Processors from Texas Instruments, and he will tell us more about the new products Texas Instruments is launching here at the show. Please go ahead.
Thank you, Wolfgang. We're introducing 6 new processors as part of our KeyStone family. We're up to approximately 20 processors introduced in the last 2 years. These are unique, and it's the first time that we brought a quad-core A15 ARM subsystem into the play of an infrastructure device. So we believe it's the first one in the market. Its purpose is threefold. One is we go after purpose-built servers. And what I mean by that is we're not replacing the Intel core processor in a server. We're an adjunct processor targeted at math code processing for very high computational problems, such as weather modeling, financial modeling. We're also going after the enterprise and industrial markets with embedded processing. Again, these devices have A15s, and they have anywhere from 1 to 8 of our high power performance DSPs. They have network co-processors, built-in 1 and 10 gigabit Ethernet switching, so you can have multiple ports without an external switch. And they're really designed to go after these different markets, whether it's a low-end router, a session border controller, or whether we're moving it into medical imaging, industrial control, or the last place you might just see it is as a layer 2 or layer 3 data plane processor in a base station.
One question. I was told that the software is not at the same level of the multicore processors up to now. So it means the software available nowadays is not able to use all the advantages of the multicore processors.
So that is a significant issue in terms of how you get entitlement of the silicon. In the KeyStone family, we've put in a couple things. We call one a navigator that makes it so it determines what core to spawn the task on. Now, we also support Open MP and OpenCL on the Linux platform. But these are not for the novice programmers. It does require someone who wants to invest to be able to get all the performance out of it.
And where do you see the main applications for your processors in the embedded market?
Well, we see it in the embedded market as a competition to the existing embedded processors, whether they be a PowerQuick or something from a Cavium, where our customer base is really looking for a standard processor like an ARM. They know our DSPs well, we're the leader, but now we have a standard processor on ARM, so there's a much larger ecosystem, and they feel that in the future there'll be more ARM devices, whether from TI or from other companies. The other advantage of these processors, very low power. They range, again, you're anywhere from 4 cores all the way up to 12, and they range in power from about 6 watts to 13.
And what do you think will the future bring for your new products?
Well, the new products, we're very focused on the heterogeneous processing problems. The other side of my business does extensive SoCs for the base station and media gateway markets. These are an extension of that technology. We'll continue to upgrade the performance of the DSP core, make it wider, make it more of a vector signal processor without losing the core advantages we have today. And we'll continue to follow the roadmap of the RISC processor with ARM into 64-bit and beyond to continue to give customers a range of software-compatible platforms from low to high.
And are your products then prepared for the Internet of Things?
They are very prepared for the Internet of Things, but my particular product lines tend to be behind the Internet of Things, not in the Internet of Things. So I tend to be in the infrastructure, but we have similar product lines from a sister group that is very targeted at the device level.
Okay. Thank you very much.
Well, thank you.